So, hello everybody. Welcome to the first This is Learning conference. Today, is a good day for everybody. We would like to learn together. We'd like to have fun, and I hope everybody will enjoy it. So, for the first talk, we have with us for our Aakansha. She is a food enthusiast and an open source maintainer and a big foodie. So, Aakansha, please start our talks.
So, hello everyone. Good morning, evening, afternoon to everyone across the world. First of all, a huge shout out to the entire team for organizing this amazing conference, like 4 tracks, 70 plus speakers. It's a lot to manage. So, a huge shout out to all of you. And I'm super excited to be here and thrilled to start off with the keynote. So, today I'm going to talk about Canvas Chronicles crafting text containers. Well, text containers are one of the most widely used features, and I'm pretty sure all of you would have used this at some point, be it any whiteboard. So, in my talk, we'll be diving into how these text containers work under the hood in the Canvas, and I'll be also sharing some insights on how it's built in Excalidraw, which is an open source Canvas based editor for sketching hand-drawn like diagrams. So before we actually, I hope everyone is able to see my screen, right? Yeah, I think. Yeah. So yeah, before actually I dive into the talk, let me quickly introduce myself. So I'm Aakansha. I am an open source developer and a FOSS enthusiast, as Ahmed mentioned, and I'm a maintainer of Excalidraw, Mermaid to Excalidraw, React tags, and more such libraries. And I also lead the FOSS meetups in Bangalore. FOSS United is basically to promote the FOSS ecosystem in across India, and I lead the Bangalore chapter. And these are my socials. So yeah, I would love to connect with all of you. If you want to talk about front end, JavaScript, React, accessibility, Canvas, open source, anything, I'm all in for that. So yeah, let's connect. And with this, let's get started with the talk. So first of all, let's understand what exactly is a text container. So by text container, what I mean is any shape which has the capability to attach some text. So it can be a rectangle, an ellipse, a diamond, maybe a custom shape like star, any such shape to which you can attach to which you can add the capability to attach some text. That's basically a text container. And let's consider this example where you have a regular text and a container. And if I combine both of these, it becomes a text container. So you can see that the text is now getting wrapped inside the container, and that's what is a text container. So for the users, it would look like, hey, it's just a shape with some text in it. But behind the scenes, there are two separate elements. The container is a separate element and the text is a separate element. So since we are actually deep diving into how this feature is built under the hood in Canvas, so let's keep a note of this. And now, before building any feature, we as developers have to come up with a list of basic minimal requirements which are needed to build a prototype. So let's discuss the basic minimal requirements to build a prototype when it comes to text containers in Canvas. So the first requirement is we need some way for the user to attach a text to a particular container. So some UX, that is like the first thing which we need. Number two is we need a way for the users to attach a text, we need a way for us in the code base so that we know that, hey, this particular text is attached to this particular container and this container has this particular text. So basically a relationship between the container and the text. And the text now, since it's part of a container, it should not be treated as an individual element. Rather, it's now the entity of the container. So whatever actions you apply to the container, let's say you are moving the container, copying the container, you need to copy the text element as well. So all the actions which are applied on the container should be replicated to the text element as well. And the last and the final, the text should always stay inside the container bounding box, which means that the text should never go outside should never go out of the container. And this is like the most important requirement. So we'll be deep diving into each of this requirement, but let's first finalize how do we want to represent an element on the canvas. That's like the starting part. So let's consider this base JSON, which we are going to use to represent an element in the canvas. It has the ID, which is basically the unique ID used to represent it on the canvas. So every element will have a unique ID. The type of the shape of the container, whether it's a rectangle, a square, an ellipse, what is the shape? The XY coordinates, which are used to represent the position of the element on the canvas, the width and height, the dimensions. So this is the bare minimum JSON. Rest all attributes are basically for the decoration purpose, which will keep on getting added as you add more and more features. So let's consider this bare minimum JSON to represent the element on the canvas. Now let's move ahead with the basic set of requirements, and let's go to the first requirement. So the first requirement says that we need a way for the users to attach some text to the container. Now, if you have used this feature in any whiteboard, one of the most intuitive ways to use this feature is you click on the container, press enter, and you start typing. And whatever you type, that particular text gets attached to the container. And that's one of the most intuitive ways across all the whiteboards. And keeping this in mind, let's actually consider this as one of the ways for the keyboard users, that pressing enter on the selected container is one of the ways. For mouse users, maybe double clicking on the center of the container, maybe some way with the context menu you want to build, maybe some UI button in your app, which also helps you to attach the text to the container, or maybe something else which is not even listed here. There can be multiple ways to build a feature. I'm not going to dive into each of it. That is not really the scope of the talk. But still, why am I mentioning all these requirements? Well, there is one common thing across all these requirements, and that is to achieve any of these ways, we need to first identify the target container in the canvas, which is the container the user is actually targeting on the canvas. That's what we first need to identify. So how do we do that in Canvas? So let's consider this container, which is a rectangle, which has some XY coordinates and some width and height. And this is the user coordinates, A comma B, which you can see. And what I need to what I need to find is whether this user is hitting inside the rectangle or clicking outside the rectangle. And how do I actually find it out? So Canvas is basically an opaque element. You cannot really inspect. You cannot really say that, okay, just add a event listener to this rectangle and let me know when user actually clicks on it. It doesn't happen like that. So what we need to do is, firstly, we know the user coordinates. We need to check whether it's between X and X plus width, that is the range, and the Y coordinate or the B is between Y and Y plus height. So if A comma B is within the range of this container, then we can say that, okay, it's actually hitting the rectangle or the container. Now, I have a quick demo to actually show this. So let's actually go to the demo. So this is the same function which basically checks, is hitting container, which basically checks whether the client coordinates, which is client X and client Y, where the user is actually hitting, is it within this container range, container.x and container.width and container.y and container.y plus height. If whether client X and Y are within this particular range, that's what it is checking. Now, as I'm actually clicking on the container, it should show me a selection indicator when I'm clicking inside the container. And when I click outside, that indicator should be gone. That is the whole motive of this demo. Now, since I'm clicking, the first thing which can come to my mind is, okay, let me just add a click listener and see how it works. So let's just do that. I have a click listener here, and I can check that, hey, is it hitting the container? If it is hitting the container, let me render the selection indicator, else let me just hide it. So with this, let's see how it works. So let me just refresh, and if I click inside, you can see the indicator container is hit. If I click outside, it is gone. Inside, it's a hit. Outside, it is gone. So this is working. Now let me do some more testing. Is this a hit? this is not a hit, right? I am just dragging my pointer. It's not a hit, but it is actually considered as a hit. Is this a hit? It's not a hit. So this is a false positive, and this is not the way it should work. So we cannot really rely on the click listener to determine the hit region or the hit the target container on the canvas. So how do we fix it? So there are other events which get triggered when you are actually clicking on the canvas as well. So when I'm pressing the mouse pointer, the pointer down event gets triggered. When I'm moving the mouse pointer, pointer move event gets triggered. And when I leave the mouse pointer, pointer up event gets triggered. And after this, click event gets triggered. And that is why you see container is hit, the indicator. So what if I can calculate the distance between the pointer down coordinate and the pointer up coordinate and check if it is within some threshold, let's say 10 pixel. If it is within some threshold, then I'll say that, okay, it's a hit, or the user is actually clicking on the container. Otherwise, it's a drag. So in this case, it's surely way more than 10 pixels. So it's not a hit, it's a drag. But let's say if I click somewhere here, in this case, the pointer down and pointer up coordinates are so close to each other that the distance between them is close to 0 or maybe 1 or 2 pixels. So in this case, it can be considered as a hit. So let's actually try out this approach of using pointer down and pointer up coordinates instead of click listeners. So let me comment this part. And I already have the pointer down coordinates here, where I'm storing the client X and client Y coordinates. And I already have the pointer up coordinates here. So if the distance is less than equal to 10, which is the threshold, I'm just calculating the distance between the 2 points. And if it's a hit, let me just render the selection indicator, or let me just hide it. So let's see if this works. So inside, it's a hit. Outside, it's not a hit. Inside, it's a hit. Outside, it's not a hit. So far, so good. Now let me do some more testing. Is this a hit? It's not a hit. This is what we are expecting. Is this a hit? It's not a hit. So this works fine, right? This is what we wanted. So yeah, we can actually use the pointer event listeners instead of the click listeners to determine the hit region. And this entire strategy of determining the target container in the canvas is known as hitbox testing. So once you actually, determine the hit region, you know which target is being hit. All you have to do is just add a text area on top of the canvas so that user can actually start typing, and the position is absolute because it's placed on top of the canvas. All the styling, if you notice, margin 0, padding 0, border 0, outline 0, all the stylings are removed so that the user feels like they are actually typing in the canvas itself and not really some DOM element. So yeah, with this, the first requirement is achieved. User can actually now start typing, and once you you can actually listen to the keyboard event or whichever way you want to go ahead with after you have identified the target listen or target container. So with this, the first requirement is achieved. Now let's go to the second requirement. That is, we need a way in the code base so that we know this particular container has this particular text, and this particular text belongs to this particular container. So for that, let's just have some basic assumptions to simplify it. The first one is a single text can belong to a single container. A single container can have a single text. So it's basically one-on-one relationship between the text and its container. So this actually simplifies a lot of things, and that's what we are going to consider for this entire talk. So with this, let's actually look at the text element JSON. This is basically the same JSON which I showed a couple of minutes back. It has some extra attributes related to the text, like text align, font size, font family. So what I want to do is, by looking at this JSON, I should be able to identify that is it a regular text element or is it a part of text container. And since every element has a unique ID, what we can do is we can just add a container ID to it, which is basically ID of the container to which this text is attached. So if a text element JSON has a container ID, then it means that it is a part of text container. Otherwise, it's a regular text element. So one-way relationship is done. While looking at the text element JSON, I can identify whether it's a part of a text container or a regular text. Now let's achieve the same thing on the other side as well, on the container side as well. So let's look at the container JSON. It's the same JSON which I showed you a couple of minutes back. Again, I want to know the same thing here by looking at the container JSON, whether it's a regular container or a text container. So the same strategy let's apply. Let's add a bound text element ID, which basically is the ID of the text element, the ID of the text element which is attached to this particular container. And here actually you can play around with this approach. So for now, I have assumed that you have a one-on-one relationship. A single container can have only a single text element, but you might want to have multiple text elements attached to a single container as well. In that case, you can make this as an array of text element IDs, and you can even leverage this approach to different kind of attachments, like attaching a line, attaching an arrow. And in that case, you can just make it an array of objects. So you store the type of the element as well. But yeah, for the scope of this talk, let's simplify it and just keep it limited to a single text element. So yeah, with this, actually, the second requirement is fulfilled as well. Now we are able to identify the relationship between the text and the container. So let's jump into the third requirement. The text should no longer be treated as an individual element because now it's the entity of the container. So whenever you move the container, the text should move as well. Whenever you copy the container, the text should be copied as well. So now with fulfilling the previous requirement, what I can do is when I'm moving the container, I can check whether it has a bound text element ID set. Then let me move the text element as well. When I'm copying the container, I can check, does it have a bound text element ID set? Then let me copy the text element as well. So fulfilling the previous requirement fulfills this requirement very easily. And as you can see, this is the progress. So as I'm resizing, the text element is also getting adjusted. If I'm moving, the text element is also moving along with the container. So this is the progress till now. But the text is still going outside the container. So let's look at the fourth and the final and the most important requirement, that is the text should always stay inside the container bounding box. So for this, let's first understand what exactly is the container bounding box. So depending on the shape of the container, the bounding box can get complex. As you can see, the red outline is actually the bounding box. So for the rectangle, it's very simple. It's basically some padding from all the sides. But for the ellipse, it's like the largest rectangle inside the ellipse. For the diamond, it's again the largest rectangle inside the diamond. So depending on the shape, it can get complex. For the scope of this talk, we'll keep it limited to rectangle, which has just a 5-pixel padding from all the sides. But if you're interested in discussing the bounding box for more complex shapes, sure, we can catch up after the talk. So yeah, now this requirement we need to fulfill in two scenarios. Number one is when the user is actually typing in the text area, where that is the DOM, and when the user actually submits the text, that is in the canvas. So in these two cases, we need to make sure that the text never goes out of the bounding box. So let's look at the first scenario, the DOM, the text area. So this is again easy to achieve because of the CSS. So what we can do is we can just give it some width and height, and with the help of attributes like word break and white space, we can actually achieve this to make sure that the text never goes out of the container bounding box. So once you do this, this is what will happen. So if you see, when I'm trying to edit the text is actually getting wrapped because of these attributes which I just applied. And if you actually leave the text and it goes into the canvas, it's again unwrapped, right? Because we haven't yet implemented that part. So this is the progress till now. Now, how do you achieve the same thing in Canvas? So in Canvas, it's not that straightforward. In Canvas, you cannot say that, hey, if the text doesn't fit, go into the next line. Canvas even doesn't support multi-line. So in Canvas, we really don't have any easy way to do this. So what we have to do is we have to come up with our own wrapping algorithm to imitate the text area word break behavior so that it is in sync with the DOM, it is in sync with the text editor. So we need to write our own wrapping algorithm, and for that, there are a couple of rules which we need to strictly follow to make sure that the text never goes out of the container bounding box. The first two rules are really important. We need to break longer lines when they exceed the bounding box width. And we need to also break longer words when they exceed the bounding box width. These two rules are the heart of the word break algorithm. The third one is a browser-specific behavior, which I'll cover in a while. But let's look at the first two cases. Let's have examples for the first two cases. So, hi, this is long line, so should break. This I want to fit in this container. Clearly, it cannot fit. So it actually breaks at word long, should, and break. This is how it happens in text area. We need to write our own wrapper algorithm so it breaks these in these words when you have longer lines. So you can keep it in sync with the text editor. And for longer words like internationalization, it cannot fit in this container. So you can see that it breaks at character N. Again, the same thing which we need to make sure in our wrapping algorithm to keep in sync with the text editor. Now, these two rules are, these are the main rules as I mentioned, and this will majority cover most of the scenarios. Now, as I mentioned, there are some browser-specific cases. Let's look at this example. Hey, word hyphen break. This is a hyphenated word. So as per the previous two rules, this is how it should work. Since word hyphen break cannot fit in the first line, it actually goes to the next line. But browser have some specific ways to handle it, and it doesn't work like this. Instead, it works like this. So it actually treats hyphen as a delimiter. So this is one of the cases which you will need to handle in your wrapping algorithm. And there are more such cases like this. As you do more and more research, you will come across more such browser-specific cases. So this is like additional things you need to take care of to make your wrapping algorithm more and more strong. So yeah, so we discussed our wrapping algorithm. We know the rules. We can come up with our algorithm, right? We all can come up with the implementation of the wrapping algorithm. Now, the next thing which I would like to cover is I'm continuously mentioning that the text should not go out of the container bounding box. Now, how do you make sure that it happens in Canvas? Because in Canvas, it means that you need to measure the text, measure the width of the text, right? That's how you can say that, okay, if the width exceeds the bounding box width, I just need to wrap it to the next line. So in Canvas, there are a couple of approaches to measure the text. The first one is the DOM measurements. That is very straightforward. The second one is a mixture of DOM and Canvas measurements. And the third is the Canvas measurements. I'll be going into all three of these approaches, and we'll see what are the pros and cons of each of it. And based on that, you can take the call which approach you want to try out. So let's look at the first one, the DOM measurements. In DOM measurements, what you do is you take a text and put it into a div, remove all the styling so that you can get the exact offset width and height. And this is what you are going to use in the text, in the DOM, as well as in the Canvas. So yeah, and when testing this behavior across different browsers, this is what was found. So you can see that the width is same across Chrome, Firefox, and Safari. The DOM width is exactly same, but do you notice that the height is different? And why is it so? Why the DOM height is different when I'm using the offset height? So the reason is that there is a property called line height, which all of us would be aware of, but it defaults to normal if you don't set it. And the browser has different way of treating this normal. They have different values. And that is the reason the height is the discrepancy of the height. So to solve this, we need to hard code the line height, and we can actually give it some values like 1.2 and 1.25 are the most recommended values. So I'm going ahead with 1.25. And once this is done, you can see that the height is same across all the browsers. So this is something to keep a note of if you're using the DOM measurements. So with this, I can see that, yeah, it works best with the text editor because DOM measurements are best compatible with the text editor. There will be never any discrepancies between Canvas and the text editor because both have exact same measurement. And it works pretty well cross browsers if you are taking care of the line height. So yeah, these are the pros. Now, there are cons as well. So this can turn out to be very expensive for Canvas because each line, each word, and each character has to go through the DOM measurements, which can turn out to be pretty expensive. And because you have to use the word wrap algorithm. And it will not work in Node.js if you want to render it on the server. So yeah, so let's see if we are able to overcome these cons in the next set of approaches. So in the hybrid measurement, as I was mentioning, Canvas has a measure text API, which you can use to calculate the width of a given text. So we will be using this measure text API only in our wrapping algorithm. The DOM will still stay with the DOM measurements. That is why the name is hybrid. So this is how you can use it. You just get the context of the canvas, use the measure text API. There are a lot of metrics which you get, but we are just interested in the width. So when using this measure text API across different browsers to calculate the width, this is what was observed. Now you can see the DOM width is same, but the canvas width is slightly differing across the browsers. And why is it so? Here, actually, we don't really have a way to solve it because this is the nature of the API. The API is actually inconsistent, not consistent across all the browsers, slightly inconsistent. So this is something to be aware of if you are using Measure Text API. So you might want to have some offset to account for it. And yeah, I have a quick demo to compare the performance of DOM and Canvas. So this is a huge text which I'm using, and what I'm doing is I'm actually breaking it into words, and I'm calculating the width of each word and summing it up to calculate the width of entire text. And this I'm doing 10 times to compute the average time taken by DOM to compute the width of the entire text, and average time taken by Canvas to compute the width of the entire text. So let's see how it goes. So average DOM time is 4.81 millisecond, and Canvas is just 0.3 milliseconds. So it's already 93% faster than DOM. That's amazing. Let's try it multiple times. 94, 95. This is really good. This is a huge improvement because it's like 95%, almost 90+% faster on my device. So with this, I can actually say that Canvas measurement is 85 to 95% faster than DOM measurements. It depends on the browser and device. So would be great if you can also try it and share how it works for you. But here it works 95% faster most of the cases in my device and browser. And there are slight discrepancies, as I mentioned. So you just need to take an account for it as well. And yeah, this will still not work in Node.js because you still depend on DOM measurements for the text area. So let's see if we are able to overcome in the next approach. So the last final approach is canvas measurements, which will be purely using the canvas. The canvas, there will be no DOM dependency here. So as the name suggests, we should be able to move away from, we should be able to support Node.js as well. So let's see how we can do it. So for this, we need to come up with a way so we can compute the width of the entire text using the measure text API. As I mentioned, Canvas doesn't support multi-text or multi-line. So we need to come up with a way so that we can calculate the width of the multi-line text. And same, we need to come up with a way to calculate the height as well with the canvas. So let's see how we can do it. So let's consider this text, which is a multi-line text. What we can do is we can split it into lines and we can calculate the width of each line, and whichever width is the largest, that is the safest width to take. So in this case, page when looking at it has the largest width. So we can go ahead or safely go ahead with this and take it as the width of the entire text. And for height, what we can do is we all have already hard-coded the line height, multiply it with the font size to convert it into pixels, and we already know the number of lines, split it by number of lines, and calculate the multiply this line height into line count, and that is what will give you the entire height of the text. And that's like a very safe way to do it because again, this is consistent across all the browsers, since we are using our own line height, and there will be no discrepancies at all. So yeah, with this, we can actually support Node.js because we simply moved away from DOM completely. And to simplify, these are this is the gist of all the three approaches. So DOM measurements works the best when it comes to discrepancies. It has zero discrepancies between Canvas and text editor, and zero discrepancies across browser as well. Hybrid has discrepancies, but it is performant. And Canvas measurements is the best when it comes to performance, and it also supports Node.js. So Canvas measurement is like a win-win situation. So yeah, depending on what you want to go ahead with, you can, but we do try out all these approaches and see which suits the best. I would go ahead with Canvas measurements in this case. So yeah, so let's actually discuss some performance improvements which we might want to push to make our feature and algo more faster. So we can actually store the wrap text in the text element JSON because when you are, let's say, moving the container, you don't really want to trigger the wrapping algorithm again and again. So we can actually keep a copy of it in the JSON as well. we can actually cache the width of the each character when breaking the longer words. The reason being, every language has a limited character set, so there is a high chance that the characters will be repeated. So I have a quick demo to showcase this. Again, it's the same text, long text, but instead of breaking it into words this time, I'm actually breaking it into characters and computing the width of each character and summing it up to calculate the width of the entire text. Now, in this case, as I click on submit, it will be using the cache more and more. So let's see how it works. So for the first time, it take without cache, it's 1.59 millisecond, and with cache, it's just 0.19 millisecond, because as you can see, it's a long text. The characters are already repeated. So it's already 87.5% faster for the first time, 90%, 93. So again, I can safely say that it's at least 90% faster in this browser and device. And that's again a huge improvement as well. And yeah, so depending on the browser and device, it can be like between 85 to 95% faster. And we can improve the wrapping algorithm by using techniques like binary search to find the longest text quicker. So these are some of the performance improvements which you can apply. And with this, I would like to wrap up with the takeaways, what we have learned so far. We learned about hitbox testing to identify the target container in the canvas. Canvas doesn't support multi-line, so that is something to be handled. And for the same reason, we need to imitate the word break behavior for Canvas as well to keep it in sync with the text editor. Canvas measurement is a huge improvement over DOM measurements, and it supports Node.js as well. And caching and techniques like binary search can make your algo a lot more faster. So yeah, this is basically this. You can scan this QR code to get all the demos, and you can try it out on your device. And let me know how it works for you. I would love to know. And yeah, these are all the demos and all the socials. If you want to connect with me, feel free to reach out to me if you have any questions or any suggestions you want to make. And yeah, I'm an independent open source developer, so please support me, and that would help me to contribute more to open source. And yeah, you can check out my GitHub sponsorship profile for that. And with this, that's all I had. And thank you so much. I had a great time. Again, a huge shout out to the entire team, and thank you, Santosh, for having me. So yeah, I had a great time. Any questions, I can take it offline as well.
Okay, thank you very much, Aakansha. It was really, really interesting. So yeah, guys, don't forget. So we have 4 different tracks. So you can find yeah, the schedule on our website. So thank you very much, Aakansha, one more time, and now we'll go to the different tracks. Thank you very much. See you later, guys.